Here we've got a 3x3 system of equations in x, y, and z, and we want to solve the system. As always, we're going to put it into a matrix first of all. So my x's are 3, 1, -1. My y coefficients are -2, -1, and 1. And my z's are 1, 3, 3. And the constants will be -2, 5, and 1. And what we're going to do is, for the most part, use the Gaussian algorithm. So first step, make sure that the matrix that we have is not a zero matrix. We're good. It's definitely not a zero matrix. And then we're going to find the first column that's not zero. It's not all zero, and that is definitely all the columns. So the first one, the 3, 1, -1, those are not all zeros. And then what we would do next is identify the topmost entry that's not zero. And in this case, it is the top entry. It's the 3. And we want to make sure that that top entry is not zero. And if it is zero, we flip it with the next one. And then the goal after that is to turn this into a leading 1 by dividing out whatever value we have there, the 3. So I don't want to do that. If I do that, I can see I'm going to get a bunch of fractions in the rest of the row. And I kind of hate working with fractions. So I know that my goal here is to turn this thing into a 1. I can achieve that a lot easier than dividing by just simply swapping 2 rows. So I'm going to do that instead. I'm just going to sidestep the Gaussian algorithm and swap rows 1 and 2 so I can get that 1 up there in my leading entry. And that's just going to make my life a little bit easier. So I'll just do the swap. And then the next step of the algorithm is we use this leading 1 to get rid of the values below. And that's just going to be subtracting multiples of the first row from those remaining rows if I have to. So what I can do here is row 2 is going to be row 2 minus 3 over row 1. And row 3 is row 3 plus row 1. So notice I am doing 2 row operations at the same time. You do want to be really careful with this. In general, it's not the safest practice. But the reason why I'm okay to do it here is because the second action that I'm doing is only calling on row 3 and row 1. And row 3 and row 1 are both completely unchanged by the first action. So the first action only affects row 2. I'm not using row 2 in my next calculation or any of the later calculations. So it's okay to do something as long as it doesn't call on something that you're changing at the same time. Is that's where you might start to do something like a really bad step you might do is something like, oh, I'm going to do this one is going to become row 2, is row 2 plus row 3. And then, oh, look, I can also cancel this out by doing row 3 is row 3 plus row 2. And then what you'll see there is it's actually just going to wipe out both of those rows. But you can't really do that because if you change row 2, it's not going to be the same thing here. It's going to completely change that. And then when you add the row 2 here, it's a different row 2 than the one you're seeing in the matrix. So you'll lose that if you try to do too much at once like that. So you do want to be careful if you're going to do multiple steps. But generally, like, it does save some time. So as long as you're careful, you should be okay. Yeah, so going ahead, the whole point is to get a 0 here. -2 minus 3 of -1, so plus 3. And 1 minus 9 is -8. -2 minus 15 is -17. And I'm going to add the rows, 1 plus -1. And 3 plus 3 is 6. And 1 plus 5 is 6. So this actually worked out really nicely. I wasn't planning that, but there you have it. So we actually have this in a sort of row echelon form. It's not reduced row echelon form, but it's pretty easy to get there. So what I can see here, if I'm going to follow the actual algorithm, I am going to make my way over to the next column. Well, basically what I would do is sort of ignore the first row and then find the next non-zero column, which is the second one. So now I'm going to work here. And now again, ignoring the first row, this is my lead entry and I want it to be in that top place. And it's there. And it's a 1, so I'm actually good to go. And then what I'd want to do here is use that 1 to eliminate every other entry in the column. So now what I'm going to do is actually just add to row 1 plus row 2. And so I'll have 1, 0, -5, and -12. And this will be 0, 1, -8, and -17. And 0, 0, 6, and 6. And so that column is now done. And so that row is basically done, aside from the eliminations I can get later. So now we're basically ignoring the first 2 rows and identifying that the third column is the one that we want, because it has it's the first non-zero column. But we still do need all of that information, so I'm not actually going to cross it off. And we've got that 6 there. It's at the top where we want it to be. We want a nice non-zero there. It's not a 1, so I'm going to turn it into a 1. In this case, division makes sense because, well, first of all, there's no other rows for me to add to it to reduce it. So, for example, I can't do row 3 is row 1 plus row 3, because if I did that, I'd get a 1 here. I would actually lose the 0 that I already found, and I don't want to do that. Those zeros are important. Those zeros are what I want. They're the goal. So I don't want to add row 1 to that, because I'm going to lose some of those zeros, even though I will get a 1 here. In this case, like, really my only option is division, because I don't have any other rows to play with. I want rows below. I don't have any. So I am, just going to divide by 6. And fortunately for this one, it's, a pretty easy division for the whole row. So I'll do row 3 times a 6th. And 1, 0, -5, -12, 0, 1, -8, and -17. 0, 1, 1, 0, 0, 1, and 1. And that tells me Z is 1, which is good. And now I'm going to use that 1 to eliminate the entries above it, and I'll just add multiples of row 3 to rows 1 and 2. So 2 is row 2 plus 8, row 3. And so I should have this is my 0, 0, 1, 1. This will be 0, 1. I'm going to add 8 of it to wipe it out, and that should give me -9. And I'm going to add 5 of it here, which is 1, 0 plus 0. -5 plus 5 is going to wipe that out, and then I will get -7 there. And so that's going to give me that y is -9, x is -7, and so that's my solution. And we're done.